Good afternoon, everyone. Thanks for joining us today. We're going to talk language of filtration 2, specifically about air filtration. Sorry, there's a delay in there. Didn't mean to click twice. My name is Gabriel Blevins. I've been with Donaldson Company for 12 years in a variety of roles. Currently, I am a training specialist in our engine aftermarket team. Our agenda today, we're going to talk some air filtration basics, some of the common industry terms. We're going to talk about air filter service life, and I'm hoping to give you guys some good takeaways today because one of the things I'm going to do is break down some misconceptions about air filters and their service life. And then finally, we're going to talk some buying choices and help you make some better decisions on protecting your investment. So our objective today, it's to understand air filtration language in simple terms in order to make more informed maintenance and buying decisions and improve the protection of your equipment. So again, our entire language series is designed to do this very thing, just help you understand some of these terms better, what they mean, and it's all about helping you make better informed buying decisions. I like to start with a story about Donaldson and how we got our start. We've always been known as an air filtration company primarily, and really that's because how we got started. And we got our start through Frank Donaldson over 100 years ago. Frank was a salesman for Bull Tractor Company. Frank had a customer in Utah who had short engine life problems, a dusty environment, dust in those engines, frequent rebuilds. So Frank decided to be a solution provider and engineered and installed the first air filter for an engine that you see pictured there on the right. Frank fabricated a wire cage and put a cloth over it and solved that customer problem. So Donaldson Company got our start that way, and we continue to carry that philosophy now. We don't like to just make and sell air filters. We like to be a solution provider. Let's start talking about some of those terms in air filtration. Air filtration is different than liquid filtration when we talk about the efficiency of the filter. And as you know, efficiency of a liquid filter is measured by its ability to stop contaminant of various micron particle sizes. And we don't do that in air filtration. Air filtration efficiency is simply the mass of contaminant. So it's the mass of dust that's allowed downstream versus the mass of dust that's fed to the filter. And I'm going to talk a little more about that in a moment. Capacity, that's how much dust the air filter can hold before it reaches its maximum restriction level, and that determines the life of the filter. So just how much dust can it hold? And restriction, of course, is a resistance to airflow. Just like in a liquid circuit, Donaldson always strives to design a better filter media with lower resistance, because if you can have lower resistance across that air filter, of course you can get more life out of it. And that resistance is measured. If you look at this little simple circuit here on your screen, it's measured on the downstream side. So the engine's pulling air through that filter, and as the filter loads with contaminant, that restriction level is going to increase, and that engine is going to keep pulling, but it creates more vacuum, and that's what you're actually measuring by resistance, is the vacuum pressure on that clean side. And we're going to talk more about that in a moment. This is a busy slide. I'm not going to talk all the way through it in detail and talk about the math behind it, but what I want you to understand about air efficiency is how the test standards are designed and how everyone tests filters in the industry according to the standards. And basically it works like this. Filter has air pulled through it just like it would on an engine in the real world, but in the test lab has air that's pulled through it, and a contaminant gets added to the airstream on the upstream side. And you just keep feeding contaminant to that filter until it reaches a maximum restriction level, and then the test is terminated. Then you go and calculate how much dust was fed to the filter versus how much made it pass, and that's how efficiency is measured. So it's simply a mass of dust, how much was fed to the filter over that life of the filter versus how much made it through. Here's something to think about. For every gallon of diesel fuel burned for the combustion process, 15,000 gallons of air are used for that. So if you think about that, while that engine's running, it's pulling in a mass volume of air all the time. And the reason that's important to understand is that with that mass volume of air being pulled in all the time, that's a lot of opportunity for contaminant to be pulled in. And you only get one chance to clean it. There's only one pass through that air filter before it goes onto the engine. So just some good food for thought for you. High efficiency air filtration is very important, especially with modern diesel engines. According to Cummins engines, it doesn't take much contaminant at all to cause damage. So according to Cummins, 1 gram of dust per horsepower is enough to destroy a diesel engine. So you're pulling in a mass volume of air all the time. That's a lot of opportunity for contaminant. You only get one chance to clean it, and it doesn't take very much to cause that damage. Let's talk about different efficiency levels. So we talked about how 1 gram of dust is all it takes per horsepower to cause damage in that engine. Well, how much is 1 gram? If you look at the screen here, these little glass vials you see down the bottom, to give you an idea of scaling on those, each of those glass vials is about as big as your pinky finger. So that little bit of dust in the bottom is showing you how much dust for various efficiency levels you have. This is based on every 1,000 grams or 1 kilogram of dust that goes to the filter. What you see in those glass vials there is how much makes it past the filter. So for every 1,000 grams that go to it, this is how much makes it pass at various efficiency levels. So the one on the right is 1 gram of dust. That would be a 99.9% efficient filter. And you see that's not very much dust there. The other 2 vials, and that one, by the way, is a typical cellulose media efficiency. That's your cheaper paper-based medias. Real common air filter out there. The other 2 are some of Donaldson's premium medias, the UltraWeb and the UltraWeb HD. And you can see they have a much higher level of efficiency. And we'll talk more about the UltraWeb media in a little bit. In air filtration, some dust on the air filter is actually desirable. The dust layer makes the filter more efficient. This is true for both plain cellulose and UltraWeb media, which you see pictured here under microscope view. This is why we say dust filters dust better than filters filter dust in air filtration. So if you look at these this media under microscope view, 2 different views here. The one on the left is what the clean UltraWeb media looks like. And if you notice that thin spider web layer on the top of the media there, that's where the UltraWeb comes in, and that's where really all the magic happens behind the performance of that. On the right is what that UltraWeb looks like loaded with dust. So that's after the filter had the contaminant loaded on it. And what's happening here is that UltraWeb media is designed to build that efficiency layer on top and build it early in the filter life. So again, a filter, once it's loaded with contaminant and has that dust layer buildup, is actually a more efficient filter. and hopefully this is a big takeaway for you guys today, a clean air filter has not built its efficiency yet. So, we like to say, it sounds counterintuitive, but we like to say that a dirty air filter is actually a good air filter until it reaches the end of its service life. So if a dirty air filter is a good air filter, then how do we know when it's reached the end of its life? Well, I like to kind of think about it like you're cooking a turkey on Thanksgiving. When you cook that turkey, how do you know it's cooked in the middle? How do we know we're done with that? We can't go by appearance. We can't just look at the turkey until it's cooked. We can't go by time, because times it can get you close, but it doesn't tell you if it's cooked in the middle. So we actually have to use some type of indicator. We have to measure the temperature in the middle and make sure that meat's cooked all the way through. And I like to use that analogy when I'm talking about air filter life, because it's the same thing. The only way to truly determine the end of that air filter life is by looking at the service indicator. And I'm going to give you an example of a couple of what that looks like by two different ways of servicing that air cleaner. If you look at this little table here, two different rows, and what they represent are two ways of servicing the air filter. Truck 1 on the top row there, Truck 1 is going to service that air filter on a regular schedule, which most people do. A lot of times you can't get out of that because when that truck comes in for service, a lot of times shops have to change out that air filter. It's a practice they're in, and it's hard to break, and I understand that. But the difference between that and if you look at Truck 2 is changing on service, on restriction level only as determined by that service indicator. And if you look on the right there, the difference between the two is dramatic as far as actually how much contaminant is allowed past that filter based on just these two service techniques alone. And the reason for that, so much more contaminant allowed downstream if you're servicing on a schedule only, is for two reasons. Number one is what I just explained, and that is how that an air filter actually becomes more efficient once it's in service for a while. So if you're over servicing that filter and changing it out on a schedule, then you're actually keeping an air filter in that hasn't built its efficiency level yet. So I know it sounds counterintuitive. It's kind of hard for people to wrap their minds around, because they always think, well, a brand new clean air filter is the best, and actually it's not. The second reason for this amount of contaminant allowed downstream by over-servicing is in the service process alone. You actually get some contaminant to the clean side, even with great practices, because when you pull that filter out of the housing, there is dust that's built up inside the housing. Well, some of that dust is going to go to the clean side. There's dust in the shop air. Some of that dust is going to get to the clean side. So just in the service process alone, you're allowing some contaminant to the clean side, and now you put in a new air cleaner, that engine starts up, and that dust that was sent to the clean side from service is now going to be passed on to the engine. So it's for this reason as well that Donaldson does not recommend visual inspections. That practice is not doing what people are hoping to accomplish. If they do a visual inspection and to try and determine filter life, so they pull it out, they look at it, and they go, yeah, it looks clean, I'm okay, or it looks dirty, I better change it out. You don't know how much life is left in that filter by looking at it. You actually need to use the service indicator to accurately determine service or filter life. Do you trust that indicator? Well, this is one of the reasons that people tend to do visual inspections. They don't like to trust their indicator, and something that we hear a lot is that, well, I don't service by indicators. I quit doing that a long time ago because they never turn red. I never see them, get into the red, so I don't think they work. So I just look at my filters or I change them out on a schedule. Well, I got a little video clip here to show you some of the actual mechanics of what's happening as the filter loads. I'm going to play the video clip in a second, but I'm going to explain what I want you to look at in this video before we hit play. And that is, this is a little air cleaner mounted on a stand. I use it for demos. And I'm actually pulling a vacuum through here just like the engine would in a normal flow path. And I'm going to take my hand, I'm going to slowly cover that intake port. And what I want you to do is look at how much of the intake port I have to cover with my hand while that needle on the gauge down the lower right is moving up. So watch how much of the port gets covered and watch how long it takes for that needle to get up to the restriction level, which is going to be 25 inches of water. So here goes the video. Notice I'm covering that port. I'm already well over halfway, and that needle's just starting to climb. And we don't reach restriction until now. And I had to cover just about the entire port. What this is meant to show you is how a filter really loads, the dynamics of what's happening there. This is the reason most of the time that people don't see indicators ever turn red. They're simply not running their air filters long enough. And you might be surprised by the guy from the air filter company who's telling me my filters could last longer, because that means the guy from the air filter company is not going to sell as many air filters. We're actually okay with that. We'd rather educate customers on the actual science behind what's happening here to make better informed buying decisions. And another thing, as I mentioned, I just want to reinforce the point one more time. Brand new air filters, they don't build that efficiency layer for a while, so you're actually allowing more contaminant downstream. And that's really what I care about, is protecting my customers' engines. Not just selling them air filters. I want to protect their engines. So that's why I'm hoping to give you some good takeaways on this. I'm going to talk about Donaldson Power Core technology for a moment. With modern high-pressure common rail engines, the need for high-efficiency air filtration is greater than ever before. Other demands have to be met when designing air filters, too. Due to emission standards, truck-improved aerodynamics require air filters to be placed under hood and in sometimes restricted spaces. Donaldson's Power Core technology, which we invented back in the 90s, enables us to fit difficult spaces and maintain high flow and performance needed to protect engines. I'm going to show you a little animation of how that Power Core technology works. Here's a view of the media and how it works. So if I have dirty air flow flowing through one end, this is a straight flow through filter versus traditional filters. That air goes down these channels and is blocked on the other end, and then it's forced through the media and then out the clean side. So that's how Power Core works. And if you notice, the dust is getting loaded deep down in that channel and then works its way backward. This technology enables some great performance advantages. By using this Power Core technology, you get better dust loading, up to 26% more capacity in that case. So that, again, that's going to mean longer filter life. They can hold more contaminant before it reaches restriction level. You're going to get lower initial restriction, which is going to be improved fuel economy and also longer filter life, because if I have lower restriction in that circuit, my filter can last longer. It's going to hold more contaminant. And that's due to the way the media is laid out. And the Power Core is a straight through flow, so it doesn't have that big open center to it, and the air is not making a 90-degree turn where it goes into the side of the filter and then out the end like traditional filters would be. So by doing this layout, I can get these performance advantages out of that. And to date, there's over 40 million sold. So talk about Donaldson Blue media for a moment. The microscope view you saw earlier was a look at Donaldson Blue. It's that ultraweb media. I'm going to talk a little more in depth about that. Here's two different medias that you see on your screen. The one on the left is conventional cellulose, and again, that's the most common media used in the industry out there for air filtration. It's a cheaper paper-based media. The fibers used in that are great big, and the way you have to lay those fibers out to reach a high efficiency level, it means that you have to pack more of them into the same surface area, and then you actually get higher restriction across it. So that's not as favorable. If you look at the view on the left there, that's the ultraweb media. So these are tiny synthetic fibers. And if you engineer these tiny synthetic fibers like this, you can lay them out in a way to reach the higher efficiency level, but keep lower restriction at the same time. And if you look above those two microscope images, that little illustration there above each one of them represents how the media loads. So those big black dots, think of that as a cross-section view of the filter media itself. So you cut it and you're looking at it from the side view. And the little gray dots are the dust particles and how they load on these two types of medias. And if you notice in that conventional cellulose media, the particles typically load by going way down deep in the fibers and they load up, versus the ultraweb media on the right, those particles, they actually load on the top layer and build that efficiency early on in that filter life. The difference in the two is pretty dramatic to overall filter life. The ultraweb media has a lower restriction level again across it, so it's gonna give you higher efficiency and a longer filter life as the end result. So yeah, the advantages of Donaldson Blue again, higher efficiency, you get longer filter life out of it, and potentially you're getting some great cost savings, because one of the advantages of going to Donaldson Blue in on-road applications is that we'll guarantee twice the life out of that air cleaner. And if you're interested in learning more about that, I'm going to ask you to speak with your Donaldson rep, and they can help you get set up with that 2 times the life guarantee. And again, that's for on-road applications. So some of our air language talking points for today, hopefully some good takeaways for you. The air filter, remember, the air filter sees 15,000 gallons of air for every 1 gallon diesel fuel burned. So we're pulling in mass volume of air all the time into that diesel engine. It's a lot of opportunity for contaminant, and you only get one chance to clean it. It's only one pass through that filter. 1 gram of dust per horsepower is all it takes to destroy a diesel engine. So those two things to me are pretty powerful. You know, you're always pulling in mass volume of air, one chance to clean that contaminant that's coming in, and it doesn't take much to cause damage in that engine. In air filtration, dust filters dust better than filters filter dust. That's why we actually understand the dynamics of what's happening in air filtration and try and design a media based around those dynamics. And that is, hey, capture that dust and use that dust as a filter as well. And finally, Donaldson Blue air filters, a lot of performance advantages to that media. It's our premium media. And again, speak with your Donaldson rep if interested in learning more about the twice the life on-highway guarantee.